acid. God, like,
What are you guys are talking about?
LinkedIn, LinkedIn? Everybody's like the robots. Congratulations, like everybody says the same thing in this horny. Horny?
Good morning, everyone.
Good
How are you guys doing today? Good. So today is lecture 21, and we have total 28 lecture. That means we have only 7 more lectures. Only 7 more lectures. Huh? Neither excited nor happy. I'm worried. That's true. You still have your third exam and a final exam.
What day is the math lab due again?
My math lab. I opened chapter. I forgot which chapter. 11 until Friday or something, and then for chapter 12 it's 24. Not 24. 24. Just before Thanksgiving. I forgot the date.
Last test.
I know. So I'll try to make this. So 24 is chapter 12 and chapter 11 this week or next week. No, I think Tuesday or Sunday midnight, something like that. Check on my method. Once you're done with the syllabus. Oh, which you're talking about? Exam 3 or final exam? Yeah, once you're done with the syllabus.
When's exam?
When you come back from Thanksgiving, first week of December. So you're going to come back on December 2nd. So most likely your exam will be, let's see. So December 4, and then we have 2 more classes, 9 and, yeah. It will be December 4 or December 2nd.
Okay, next, you don't have anything to do after Passover, right?
Huh?
You don't have anything to do after Passover, right?
What do you mean?
That's it.
What paper?
Before.
Guys, shh. What did you say, Alana?
Before the paper.
Oh, yeah. So your next exam will be either December 2nd or December 4th.
Gonna be so much content. How come you split it up into 2 exams?
I don't have time to grade 2 exams. That's my problem.
The 3rd exam is just gonna help you grade.
I wish you cannot grade your own peers.
I will grade another class. I'm pretty confident.
Really, I wish. Can you guys actually do that?
In AP statistics, I used to talk my teacher grade, and whenever I call my friend paper, I'll be like, I'll give like an extra point. Even if like, she loved me, so like, she would never like second guess me. I always do it for like 1 or 2 papers.
I wouldn't even look at the questions.
I would never check my own exam. I would do the question.
Then how can I trust you guys on grading?
Yeah.
As soon as I see even his name, you know, I want to be able to be fine. I don't care how well they try to get it. I'm getting so far.
So let's see how many chapters we have left. We are going to do this and then log equation. Yeah. Oh, that's it for log. Oh, we'll be able to finish syllabus before Thanksgiving. Yeah. So once we're done with chapter 12, we have chapter 13, only 13.1 and 13.3. So only 2 sections. Yeah. Wow. So we don't have enough material. I mean, not much materials left. So we'll be finishing syllabus before Thanksgiving. You're going to study during the Thanksgiving, and when you come back, your exam will be on 2nd. So I'll have enough time to grade them. I hope.
Can you also put example on the quiz? Sorry, the quiz that you said we're gonna have to do, right?
Next week, Tuesday.
Can we do one more example after like just transformation? Bro, stop acting like this, bruh.
So in the quiz, I'm going to ask transformation and solving radical equation, not radical, exponential equation. I still didn't grade the last quiz.
This
Yeah.
can be the final quiz.
Final quiz,
Cause I feel like you know so much content, so much math lab, and you have to keep in mind, you know the packet. You have
big package, yeah.
Like there's so much work and you know.
The reason I'm giving you the quiz so that you actually study after class. So if you do study after class, I don't mind not giving you quizzes. One transformation, one solving equation. So we have exponential, and today we're going to learn about log. So probably one exponential or log, and one transformation about exponential and log. Okay, let's start. Log. Log is easy as long as you remember these rules. So the first rule says log base b of the argument b. If you have the base and the argument same number, then they cancel out everything and we get 1. This is what it means under the basic properties. Oh. So when the base and the argument they are same, everything cancel out, the answer is 1. Log 1 equals 0. It's because if you look at the log function, when x value is 1 or y value is 0. So that's why log for any base, if you have the argument 1, your y value is 0. And the last one says log 0 doesn't exist. So if you have, after you solve radical logarithmic equation, if you have log 0 or log negative number, then they do not exist. Log cannot take any negative number or log cannot take any 0. Log 0 doesn't exist because when x is 0 here, log doesn't even touch that y-axis. So how can it have a solution for that? Product rule says if you are multiplying in the arguments, you have to add the result. So basically you can distribute them, but when you distribute, the multiplication symbol turns into addition. That's because when you multiply something, you get something more. Similarly, when you add something, you get something more. So multiplication symbol turns to positive plus symbol when you try to distributing a log. Same situation is for the division. When you're dividing in your argument, you can distribute to log, but since you're dividing here, that division symbol turns into a negative sign. The next one says log cannot take any power. Log hates power. Anytime you have any type of power and you have log with it, then the power comes down as a coefficient. So every power turns into a coefficient. That's why when you solve exponential equation and you have a variable on the power, to bring the power down on the coefficient, we apply log. Log hates power. The last one is a change of base. It means if you observe your calculators, scientific calculators, they do not have base in it. For example, here, look at this calculator. We have the log, but this log doesn't have any base. When you don't have any base, you have an invisible base 10. So by default, every log has base 10 without, if you don't see any log. So here, the calculator, or most of the calculators are based on log 10, base 10. Now, for some reason, if you want to find out something like this, how much is log base 3 of 2? You cannot use calculator to find that because calculator doesn't have base 3. So that's why mathematician invented a formula. They said, well, we don't need to use a special calculator to find how much is this. We can change, we can rewrite this equation into log2, into log2 and divided by log3. When you do log2 divided by log3, you're going to get the same result as log base 3 of 2. So this is called change of base. All you have to do is change your base from B or from any number to 10, and then divide your argument by the log of the base. You're going to get the result. You don't even have to use the log, you can also use ln. Or if your calculator has a specific number on the base, you can use that base and you can divide the log of the argument divided by log of the base. So all three things going to give you the same results. Calculator will do that for you. No, you punch this in the calculator and then it will give you a number. How much is this? For example, log base 3 of 2, we cannot punch this here in the calculator. We don't have base 3. So what we're going to do, we're going to do 2 log divided by 3 log. And that's the answer, 0.63. So if you need to know how much the number is, you can just use 10 base. We don't even have to use log, you can use ln. For example, here. Why is my ln here? Ln 2, oh, sorry, it doesn't work. 2 ln, not 22. 2 ln divided by 3 ln. See, the same results. Whatever you have for log, why is my log here? Log 2 divided by log 3, we have the same result for ln of 2 divided by ln of 3. So log and ln, they do not give the same answer individually, but if you do a division, they'll give you the same result. For example, look how much is log 2. Log 2 is 0.27, but look how much is ln 2. See, totally different numbers. So individually, they give totally different numbers, but their quotient is always the same. That's something cool, something interesting. Okay, good.
Why does it work like that? Like cancel out?
Something cancel out, and you're left to it. For example, what example I can give you? Never mind. When I can think of one, I'll show you. Inverse property, it says this is same as the power rule. Anytime you have a power, you just have to bring it down. And when you bring it down, you get x log base b of b. But you cannot have the same argument and base. When you have them same, they just cancel out and turn into 1. So log base b of the argument b to the x means only the power x. If you have log base b with some power y, and you have the argument b with some power x, then the b and b cancel out, and this turn into a division, x over y. So the power on the argument goes in the numerator, the power on the base goes in the denominator. The next rule says, well, let's say you have a base, and the base has a power log, and that log has a base b. And then you have some type of argument. It doesn't matter what argument you have. As long as you have all three things together, b log b, either this way or that way or that way, doesn't matter. If the base and the argument are same, then all of them cancel out, and the answer is whatever you have here on the power, on the argument. And the last one says, when you try to solve logarithmic equation, if you have the same log with the base on both sides, you're allowed to cancel them. But the condition says you cannot have anything extra next to that. For example, if you have log base b of s plus 1 equals log base b of t, then you cannot cancel them because this is extra. In order to cancel, they cannot have anything extra next to them. You have to have a single log on one side and a single log on the other side. If you have them, then they cancel out and you set two arguments equal to one another. It's just like the rule, 2 to the x and 2 to the 5. As long as you have the same base, you're allowed to cancel them. If you don't have anything extra next to them, and then you set the power equals to one another, it follows the same, right? Same concept. But the condition says you have to have a single thing. You cannot have anything extra. So as long as you memorize these rules, anything related log will be easier for you. So please try remembering them, memorizing them. And now let's do some examples. Ready? Use properties of logarithms to simplify all of this. The first one says log 100. How much is log 100? How do you know it's 2? The answer is 2, but how do you know? So you rewrite log 100 is 10 squared. Now this log has an invisible base 10 here. When you have no base, it's base 10. Krish, no laptop, please. Not Krish, yeah, Krish. Exactly, his brain works so fast. So when you have the argument and base same, you cancel all of them. So what is left? I'm impressed, Eliza.
Oh, wait. Then I get all day and always. Okay.
See, this one is easier. How about the next one? It says, let me read it if it looks weird. Good. Log base 3, and then you have 3 squared. 2, how do you know? It cancel log 3 and 3. We're left with only the power 2.
So any square, like
Any power.
where
If you have any power and the base and the argument are same, you cancel everything else, everything except the power.
if it's a perfect square,
If there is no base, it's a 10 base. For example, when you have 5, we don't see anything, but we do know 5 has an invisible 1 below, right? Same situation is with the log. If you have a just log x, there's an invisible 10 here. Always. If you don't have a base. But if you do have a base, then it's not 10, it's the number you have on the base. For example, here, this doesn't have 10 base, it has 3. Okay, the next one, let me rewrite. We have log base 3 and 1 over 81 as argument.
biggest thing,
How do you know?
the quick math. You I don't even know how to explain it. I just know it's like 3. Because 1/81, like it's just 3 to the cube, but it would be
3
like,
to the power negative 3.
I'm not explaining that. I'm telling you.
3 to the power negative 3 is 1 over 3 to the positive 3, which is 1 over 81. You know, I'm impressed how fast you guys brains are working today. Wonderful. Kind of.
Yeah.
So we cancel all 3 things and we left it negative 3. That's our answer. Eliza, question or the next question? Which one? So what's the answer for the next one? 4x. So we have 3 to the power log base 3 and here's the argument 4. Anytime you see the same base with the log, they cancel out.
Wait, what?
The logarithmic rule.
But doesn't have to. I don't know how to work. Now I can.
As long as you have the number same, then they cancel out.
What is the 4x? Power?
Not power, arguments. So you have base, you have number B, number 3, okay? And 3 has a power, which is log.
Oh,
That log has a base 3 with argument 4x.
I thought 3 was.
No.
The next one then.
Sure. It's not bad. It's log 1/100, 1/1000.
I think that is good.
Terence wanted to do it.
What's the Q for?
Quiz. It's from a quiz, my MATLAB quiz.
Oh, really? Oh, so it's just log 1/1000?
So you have log, and you rewrite this as 10 to the negative 3 power.
And then what? And then
And you have the invisible 10 base.
Log equals log equals base. Log.
hold on. One voice, guys. One mic.
10 to the negative 3 is 1/10 to the positive 3. But what is 10 cubed? It means you have 3 zeros. So 1, 2, 3 zeros.
So how do we pull a 10 out of our butt again?
Always 10. When it doesn't have a base, it's always 10. When it doesn't have a base, it's always 10.
If there's no rhythm.
Like I've been on that since day one.
It's like a new, like any number has a denominator of 1. It's like automatic.
Why 10?
Because that's what matches.
Your goal is to rewrite.
Ask him why did Albert Einstein say 10 instead of putting the above.
Exactly. I don't know why 10.
Why are
You-
you even move there?
This is the more intellectual.
Intellectual. Okay, look. Your goal is to rewrite the argument in terms of the base. Why? Because we want to cancel them. So whatever you have, observe the base and rewrite your argument in terms of the base. That's why when you rewrite, the 10 base with the 10 argument cancel out, and you left with only the power negative 3. So what's the answer for the next one?
5. What are 5?
It's right.
1/5.
I was close enough.
Close, true.
ChatGPT.
One funny thing I saw in my life was people when I told them the rule that when you have, what's this noise? When you have E and ln together, they cancel out. So what people did, they canceled out E and ln, and they told me the answer is this. Does it even make sense? Like, I didn't know, should I laugh or should I cry or should I do what? Some people gave me answer this.
I would just give him a 0 on
There's
the
an invisible one in there, right? The one in there?
But what does that mean?
This one's
No, they turn into 1. It doesn't turn into 1/5. First, you have to rewrite that. If you just cancel, it doesn't turn into 1/5. You need to rewrite ln and E, that E has 1/5 power.
right.
So 5th root turns into 1/5 power. You need to write that out. And then you see E and ln next to one another, so they cancel out. Here, they do not cancel out. Because between E and ln, there is a block between them. So they cancel out, and then it's 1/5. It's not 5th root of nothing, okay? It's 1/5 number. So do not give me that 1/5 in the exam. Not 1/5, 5th root without anything. Not negative points, but you're going to get 0 for that.
Do you have any more minutes?
Of course. Oh,
Now this one for Terrence. Don't say nothing.
this one is expanding. Expand means you're going to distribute. Expand.
Log 3 plus
Log base 2 of 3
plus
plus
log 2 of x
log base 2 of x.
and plus log
Good job. Log base 2 of y. So expand means make it bigger. How do you make something bigger? you need to distribute everything. So when you distribute between 3x and y, you have a multiplication symbol. So every multiplication turn into addition when you distribute. And guess what? In the final exam, you will have one of these distribution.
That's all you have to do?
Mhm.
Y'all think he's very good.
There is nothing to simplify. When you can simplify, you must. When you cannot, leave it
How do I
alone.
show work?
Oh, is it-
Nothing. You just expand.
I have to draw the X.
So, we all have to be like.
We had to simplify.
You go.
You'll see. The next one.
Oh,
In the next one, we have multiplication and division.
Alright, I'm ready.
Ready? Anyone else besides school? Eliza, give him a chance. Let's see what he gives.
I'll do everybody.
As log 10 to the fourth
Log, you can have it 10 invisible, no problem. Log base 4.
plus 3 log.
Oh, you're doing it together. Let's do the distribution first so people will understand what's going on.
And minus,
Minus.
will we have to put that in parentheses, the bottom, or we just put it?
No.
Okay, so then log, y.
Y square.
And then log.
But what symbol it goes?
plus.
If you do plus, then you have to put a parenthesis.
Then log root.
Square root of c. So you distribute it, but it's not simplified. So you cannot stop here. So who would like to help me with the simplification? Amar?
Why? I thought you were the intellectual side of me.
Okay, good, go ahead.
So first I will distribute the log.
We need to distribute the sign, so turn into negative. And log hates power. So every power you see,
3 log x.
Oh, I knew it.
3 log x minus
Oh, 2 log. 2 log.
2 log y.
Plus. Oh, no, negative.
No, it's minus because you're distributing log. But what is square root of z?
Oh, then we rewrite that.
Z to the 1/2. So this thing turn into z to the 1/2. 1/2 comes down, so we need to write one more line. Log base 4, 3 log of x, 2 log of y minus 1/2 log of z. In the final exam, it will be 3.5.
Wait, isn't this only just part of it now?
So we had to distribute to the 4, x cube, y square, and that. Every numerator will get positive sign. Every denominator will get negative sign. So you can do everything in one line from the first line to this line. But make sure every denominator gets the negative sign and every power turns into coefficients.
Why is the y in parentheses, but other one?
Because I tried to log y, it looks loggy. It looks weird. Loggy. It looks weird. Log x and log z doesn't give problem, but log y, see here, loggy looks so weird. Y makes a sound, x and z doesn't make a sound. So I feel comfortable. It does look loggy, right? Loggy. Okay, the next one.
Same thing.
Similar. Similar. It's little bit different. Huh? Look at the difference between B and C. B has a square root for only one term, but C has entire denominator under square root.
Oh, or do we
You can just read it for. So what happened to
See, I'm impressed, Gur. So you love log, right? I can tell. I can tell from your.
I feel like it's
See, these are fun if you remember your rules.
I'm not, bro, I have these like, these got like
Stuck in your brain?
drilled into me.
word.
Smaller, bro. The rules are like.
Stop. You might have to turn that.
Stop, you're digging
like
deep,
that.
stop.
You're digging inside.
Okay, ready? Who would like to try this? Eliza, go ahead. Before you do that, let's make it simpler first. So keep this 5x to the 6 and work with the denominator. How can you simplify the denominator a little bit? Y 7/2, Z 5/2. Z. So if you have no idea what we are doing, we rewrote log 5x to the 6, square root of y to the 7, and square root of z to the 5. So first you need to split your radical, z to the 5. So split the radical on the denominator and then rewrite the radical using a power. And now you can do everything in one sentence. Go ahead. Log of 5.
Plus 6 log x
6 log x
is 7 log y to the power of 2.
minus 7/2 log of y. You bring the integral.
Yeah, 5/2 log 8.
Log of z. That's it. It's not bad. It just distribute.
Yes, it didn't make the rectangle.
Because it doesn't create a rectangle, it creates a hand. It's a pointing finger. If I put my fingers here. Oh no, it's one finger. It's one finger, my bad.
Exactly wrong,
Okay, the next one. And probably this is the last one. Yep. Who would like to try the next one?
I'm ready.
Go ahead, good.
It would be, that's what we should, all right, if we're looking them up, then you're gonna get a, we can cancel out the
ln of e cube.
Supposed to be 3, right? So then it would be, ln, 4x, or 4 ln x.
Let's distribute so that people can see. Okay. And next, tell me what happens.
Then it would be the ln is step up. Oh.
Plus
4 ln x
4 ln x.
plus -5.
So minus 5 ln of y. So this -5 comes here, this 4 comes here. And this 4, 1, 5. Any question on expanding? Remember, one of these will be in the final exam. You may get something easier, maybe something harder. Which next line? We cannot change anything anymore. Oh, next slide. Okay. In the next slide, we are going to do the opposite. Expanded version is given, combine everything into a single log. So we are going to write a big log. Oh man, I have to open it. 1 second.
On the YouTube.
You know, I wonder in the morning, how can you have so much energy?
How much, he didn't even eat yet, he told me.
Exactly,
He
like,
was drinking no sleep, he didn't eat, and he was mad tired, he can't do math today, and then he's Bark. There's no, bark. You got a whole student tile, bro. I'm professional.
You got it inside out.
It's right now, isn't it? Oh, I'm ready.
okay, so you're going to write a big log.
Oh, wait, I'm wondering what it is.
What's wrong with this? We need to refresh your file with updates. Click save to try again. Okay, I did it. Let me restart again. Okay. Something is wrong. Save. Refresh, 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 refresh. Reopen. What's wrong with this? I don't know, it keeps saying save it, save it, save it. See? I'm gonna ignore this. Yeah, it says available. Updates are available. So what? I don't want to update. So we write a big log, and since we have a plus sign and minus sign, that means we are going to have a numerator and denominator. What goes in the numerator? Every plus thing goes in the numerator. How do you get y? So this one, he comes here as a power, so you get x cubed. Y has a minus sign, so y goes on the bottom.
And then z squared on the top.
And then we have 2 goes on the z as a power, and it has a plus sign, so on the power. So on the numerator. Every plus sign goes on the numerator, every minus sign goes on the denominator.
Oh, so
Mhm.
if there were parentheses between the second and third log, would the z be on the denominator then?
Yes. And that's all we have to do. Instead of writing log 3 times, you're going to write it 1 time and combine all the arguments together. Next one. If you want, you can rewrite first. ln of a to the 8 plus ln of 2b plus 1 minus ln of c to the 1/3. On the last example, I didn't do it, but if you want, you can write it, no problem. And then here you have a big ln. You have a plus sign and minus sign. That means you have a numerator and denominator terms.
A to the 8.
A to the 8.
Is it parentheses plus 1?
2b plus 1.
Bottom is the third root of c.
Cube root of c. Perfect. So this is cube root of c. So this argument plus this argument and this argument. These 2 goes in the numerator. And this one comes down on the denominator. So how many of these you want in the exam? There will be at least 2.
10?
10?
Yeah.
I can put them with different combination. But there will be at least 2. Any question on this? Not final, the 3rd exam. I do not make the final, but I seen the previous final questions. So there will be 1 question from expanding, This one, they don't always put it. Sometimes it comes. But mostly the expand income. Expand your loss. Okay. Next, we are going to find the value of a number using calculator that doesn't have base, any other base besides 10. So it says, rewrite log base 3 of 5 using natural log. What is natural log? ln. So they are saying, they're saying find log base 3 of 5 using ln. Good. ln of 5 over ln of 3. Mm-hmm. And then you go to the calculator and then find out how much is this.
1.36.
How do you know?
All right.
1.46?
You didn't think.
Exactly. Like,
The calculation goes to my head.
wow, see how impressive. Jack, you laughed a lot. Now tell me the answer for this one. It says rewrite log base 7 of 11 using common log. What does common log means? No, natural log is ln. So if natural log is ln, what is common log? Just log. So rewrite log base 7 of 11. How are you going to rewrite? It didn't say log, it says is common log. Log 11 and what? 1.23. Yeah, 1, 2, 3. Cool. 1, 2, 3. Any question? So in the exam, first you need to rewrite. I want to see the rewriting and then the answer. If you give me the answer without rewriting, you're going to lose points.
Yeah, man. Where, like, how should we use our calculator? Like, what
Scientific calculator. Any type of scientific calculator.
Because I don't.
TI-84 is not scientific, it's a graphing calculator. You're not allowed to use the graphing calculator anymore. Students allowed to use before, but
Share one.
I don't even have any scientific calculator. Yeah.
I'm also.
I gave you a bad idea, remember?
Yeah, library.
You can borrow from library. And if they don't have any, you can buy one from Walmart. They have 1 month free. And then return it after 1 month. Walmart has 1 month time period. But other store, if you buy it from Staple, I think they have only 2 weeks period. Okay, I have 2 more.
I want to do one. Ooh,
Go ahead, Terrence.
I don't have a calculator. Wait, no, I do have it.
Oh.
Yeah, take an educated guess.
You got it.
Yeah, let me check with him. 3.83. So what do you have, Terrence?
I can't.
Tell me the first step.
You got a button for that? I've got no button for those.
Bro, you got the Bible.
So see, you have to change this format.
No, no.
Log 479
No.
over log 5. See, Terrence, you have to rewrite using base 10.
Do that.
The base 10 is invisible.
You got to go up.
No.
Yeah,
It doesn't.
Oh, does it? No, it doesn't do that. I kind of, huh? Why did it not have? Why did this is one?
I have 3.83.
did you say 83? 3.83. The last one,
Let's see.
Nihan, the last one.
We have to use.
You have so many examples in front of you. Just copy the examples.
No, at least he's on.
I think,
True.
I think we dropped it.
Yeah, Nihan, sit next to me next time. Somewhere in the first row.
Maybe just like right there.
It's for your own good. Krish. 361. Our log 3, good. So you divide in the calculator. 5.36. And that's all you have to do. Rewrite, punch in the calculator, get the answer. Make sure you have a calculator before your next exam. The next exam has a calculator part. How many what? How many rules? So many.
How many have we done?
We did all of them. We didn't do 1 and 0. 1 and 0, you're going to use this knowledge to check the solution for logarithmic equation. So for exponential equation, you solve and then your life is easy, that's it. But logarithmic, you must check it. Log 0. It doesn't matter what base you have. Anytime you have log 0, it's undefined. It doesn't exist. Why? Because look at the graph. This is the log graph. It never touches the x equals 0 line. This is 0, right? X is 0 here. So this one is saying point x is 0, how much is the log? Point x is 0, it cannot even touch the graph, touch the x equals 0 line. So how can you have something? Doesn't exist. And log 1 is always 0, because when x is 1, our y value is 0. So that's a log 1 is always 0, regardless of your base. Question, who raised the hand? No? Okay, so we are going to do the last thing in this chapter, solving logarithmic equations. Like exponential, there are a few types of logarithmic equations. Based on the type, you follow different rules. Okay, just like remember, we had 5 exponential rules and we use 5 different starting methods. Same thing here. We have a few, I forgot how many, logarithmic situation. Based on the situation, you start differently. But we are going to use the concept is that if you have only one log, you can rewrite it into exponential form. And if we have 2 logs, 2 single log on both sides, you're allowed to cancel them and set the arguments equal to one another. So these are the 2 rules. Based on them, we solve logarithmic equations. Now in the first situation, or 3 different types. No, I think there are 4 different types. Why do I write 3? 1, 2, 3, 4. Yeah, see? I knew it's 4. So 4 types, not 3. 4 different types of logarithmic equations we have. Type number 1, there is only one log term is alone on one side of the equal sign, and there is a number on the other side of the equal sign. Like this, one logarithmic term on one side of the equal sign, and just a number on the other side of the equal sign. If we have this situation, we are going to rewrite that into exponential form. And from there, solve for x. So if ln doesn't have any base, what is the base for ln? Not 10. Log has 10. ln has e. 10. So we rewrite. Do you remember how to rewrite log into exponential?
Yes.
It's like a cycle. Base gets that as a power. and we set the result to the argument. The e to the 6 equals 2x minus 3. You rewrite log into exponential.
They have to do it.
No, because e is a number. So we have 2x minus 3 equals e to the 6. E is a number, so we have only one variable here, x. And you're solving for x. What do you do? Add 3. So we have 2x is e to the 6 plus 3. Divided by 2, divided by 2, cancel out. And we get x equals e to the 6 plus 3 divided by 2. Now you go to the calculator and find out the you write e that power thingy 6, and then probably have to put a parenthesis e. You'll see it's e.
This is E.
Oh, okay.
21.
How much? $203. So 203.89? 21? 21.
Oh, you have to be.
Okay, let's see.
No, we do. Wait, yeah.
E to the power 6, and then you're adding 3. We are dividing by 2. It's 203.21. So did you divide by 2? If you don't divide by 2, it's 400 something. Yeah, depending on your calculator. Oh yeah, you have to put the parentheses here. Otherwise, this will divide that and then add 3.
Yeah, that's right.
Order of operation does matter. Okay, since you solved the logarithmic equation, we cannot stop here. Because we got this, we have to check, does it make the ln positive or negative? If it's make ln 0 or negative, it's not allowed. We cannot accept the solution. We just have to check the inside of the ln here. We have ln of 2x minus 3. So we get ln of 2 times 203.21 minus 3. Is it a positive number, negative number, or what? You actually don't even need a calculator. You can see the answer here directly. What is 2 times 200?
It's 400.
400. What is 400 minus 3? Positive or negative? 400 minus 3. Positive or negative?
Positive.
Positive. As long as it's positive, we are safe. So we accept. If it's negative or 0, then we cannot accept. But if it's positive, we don't even have to check whether two sides are equal or not. So there, the base for ln is invisible. So I made it visible. When you made the e visible, then you rewrite log into exponential form. How do you write the exponential form? Here. You take the base b, raise your equal sign, whatever you after the equal sign, to the power, and then is set that equals to your argument. So B gets the right side of the equal sign as a power, and then that set equals to the argument. So I remember it is a cycle. Start from the base, it goes here, and then it completes the cycle with the argument. Any question on this one? Okay, try this. We have two of them. And guess what? All of these are in the final exam. So you're going to have at least one logarithmic equation in the final exam. Actually, two, my bad, two. One is in the non-calculator portion, one is in the calculator portion. One day, 2 hours. First 90 minutes is non-calculator portion, and the last 30 minutes the calculator portion. Final. Exam check and follow the same rule. We have 2 hours. First 90 minutes, the first part, last 30 minutes, the calculator part. Question, good? Or you're trying to do it? Okay. Go ahead. The first one. You have to show me the word.
So, you voted as e to the power of 5 in the first.
E to the power 5 equals 2x divided by 2 divided by 2. So x is e to the 5 divided by 2, which is 74.207. It says round to 1,000. So tens, 100,000. What's the next number after 1,000?
5. So, no, that's 6.5.
6.5. Okay, so 6.5. So you write 74.207. Yeah, if you're lucky, they'll give you something this easy. Who would like to try the next one? The next one says log base 2 of the argument 1 over x plus 1. Everything is equals to -1. Jack, go ahead. 2 to the -1 equals 1 over x plus 1. Great. So what is 2 to the -1? 1 over 2. And then the easiest method is just flip them. You can do butterfly, but see here, our x is on the denominator and you are on the numerator. Just flip it. We're allowed to flip as long as we flip both sides. Yeah. You have to flip both sides, and you cannot have anything extra. You have to have one term on one side. So one term on the left, one term on the right, you're allowed to flip. But if you have, let's say, 1 over x plus 1 equals 2, then you cannot flip, because this is extra. You have to only one fraction on one side. One fraction and one fraction. Then you can just flip. Or the butterfly, you can cross multiply, not cross, yeah, cross multiply, semicolon, whatever you want. My favorite one is just flip it. So we get, oops, x plus 1 is 2. So what is x? 1. But you cannot stop here. We have to check. We didn't check because 2 times 74 is positive. So x plus 1 is 2, x is 1. Now to check. So 1 plus 1, and this is log base 2 of 1/2. As long as this is not negative or 0, we are happy. But if you want to see whether this gives us -1 or not, does it give us -1? What is log base 2 of 1/2? The questions we did before. This is log base 2 the -1. And what happens to? All of them cancel out. So answer is, which is the right side. So we actually don't have to take all the details. As long as the middle, the argument is fine, you're happy. Any question? So one log term and one single number on the other side means convert into exponential. Now we have one more. Go ahead, try one more. The easiest one. See, that's like the easiest one. We have invisible 10. So we get x equals 10 to the power 2.2, which is what for what?
158.4893.
4893.
4.49.
489. If it was 5, then the 90 will turn into 100, and then 8 will turn into 9. Any question on this type? No question? Then we have the second type. But these are fun. See, these are fun. In the second tab, it's a non-calculator question. So you have to use your brain to solve it. So in this situation, what is happening is that we have two logarithmic terms on one side of the equal sign. And we have a single number on the other side. Like this one. Two logarithmic terms on one side of the equal sign and a number on the other side. So if you have two log, you're going to use the log formula, not formula, the rule. You're going to combine the two logs into one log. The example we did here, all these examples we did, you are going to combine two logs into one log because they're the same base. We are allowed to combine them if they are same base. If they're different base, then we cannot combine. Then the story is different. But in this class, we don't have different base. We're going to have the same base. Same log with the same base, just the argument is different. We're going to put them together into one log. So we are going to have the first scenario, a single log on one side, a number on the other side. So you're going to turn into exponential. So our first method is different, but then from the second method is same. So how do you combine these two logs? Huh? Log base 4 of what?
No. I thought it was x.
X times x minus 6. So the plus turn into multiplication equals 2. Here we don't have any minus log, so we do not have any denominator. We have only numerator. And now this is the first scenario. One single log on one side, number on the other side. So what is our next step? No. Exponential. We get 4 squared equals x times x minus 6, which we are going to distribute. My square looks so weird. Let me write nicely. There's space? Okay, I do have space. So we have x squared minus 6x. And what is 4 squared? 16. So we're going to subtract 16 from both sides. And we're going to have a quadratic equation. Exactly.
Right?
Mm-hmm. That's why not allow this calculator because this is easier. What two numbers multiply to negative 16 but combine to negative 6?
Great. 8 and 8 and 2. It's
So 16 has many choices. 1, 16, but they do not give 6. 2 and 8, they do give 6. 4 and 4, they do not give 6 when you add them. So this doesn't work, this doesn't work, only for 2 and 8 works. So what sign? Negative 8 plus 2. So when you solve, you get x minus 8 equals 0, x plus 2 equals 0. So x equals 8 and x equals negative 2. Not really, whatever makes the argument positive. So check. We have log base 4 of x plus log base 4 of x minus 6. We don't care about the right side. We only want to see what is happening here. When x is 8, we get log 8. And here we get 8 minus 6. This is positive, we are happy. This is positive, we are happy. So we're going to accept x equals 8. Then we check the other one. Log base 4 of negative 2. We don't even have to write the other thing. When you see a negative inside the log, it's automatically doesn't exist.
That's what I said.
So you have to disregard this. So you don't have to check left side equal right side. You just need to check the argument. Easy argument positive. Only if it's positive, you accept. If it's negative or if it's 0, you do not accept. Any question? Okay, you try one. Go ahead. Solve for x. Another author has modified this document. I am the only author. Why did he get another author? Updates available button to get the latest changes. Oh, no. How come he doesn't recognize me? So weird. You know, last night I was watching a video. There's a Tesla car, and then in front it's going with another carriage. You know this carriage, right? The
like a-
wheel.
Right.
Yeah. Yeah. Like it's I don't even know. Like it's like a it is Cinderella, right? The carriage for Cinderella. So there was a carriage somewhere on the road, and Tesla was behind that. And Tesla didn't recognize the carriage. So it was drawing all sorts of pictures for the car in front. First it drew a van, then a semi van, then a truck. Like it couldn't recognize the carriage. So why was I saying it? What? I had a reason of saying this. Why was I saying this? I forgot why I'm telling you this.
Think about a lot.
Yeah. This is something to do with this question, but I forgot. Oh, not this question. The technology. It says there was another author was editing this file, but I was the only one. So how come you couldn't recognize myself? And I also logged in here. So yeah. Okay, ready guys?
Yeah, I'm ready.
You are ready? Okay, go ahead.
2 to the power of 1 equals.
But before that, what is your first step?
Oh, yeah. log two, we're gonna combine the log.
Log base 2.
Base two, one minus x divided by x plus three.
Good. This time we have to division. Why?
Because combine.
Because the minus sign turn into a division equals 1.
Then give you that, 2 to the power of 1 equals
2 to the power 1 equals 1 minus x over x plus 3.
almost 5.
So solving. If you want, you can cross multiply.
And
Below 2, we have invisible 1.
2x
So, which one? This one.
to the top.
2x plus 3, and then 1 minus x.
And 2x plus 6.
2x plus 6, yeah. 2x plus 6. Or if you want, let me actually rewrite so that you can see people. 2 times x plus 3 equals 1 times 1 minus x. So that's how we get 2x plus 6 equals 1 minus x. And it's become an algebraic equation.
5, 6.
Add x, subtract 6. The 6 cancel out and x cancel out. We have 3x equals -5. So x equals -5 over 3. It divide by 3, divide by 3. So this is your answer. Do we stop here?
So we gotta check.
We have to check. So log base 2, 1 minus x, minus log base 2 of x plus 3. Now log base 2, -5 over 3 minus x. And then log base 2 of -5 over 3 plus 3. Wait, how'd you get x? It's -1 minus -5 over 3. So negative and negative turn into positive. So 1 plus 5 over 3 here, and this is 3 minus 5 over 3 here. 1 plus 5 over 3 is plus, because they both are plus. How about the next one? 3 minus 5 over 3. Is it plus or minus? 3 is bigger than 5 over 3. 5 over 3 is 1 point something. So 3 minus 1 point something. So this is also plus. Remember, you have to do it without calculator. So to check, 3 goes to 5 how many times? Once. So it's 1 point something. So 3 minus 1 definitely is plus. So we accept our solution. X is -5/3. Any question? We have only 2 more. I mean, 2 more scenario.
So you got temple.
Let me skip this and go to the 3rd scenario.
Oh, we could
Yeah. I'm skipping because you guys are tired already.
I'm not tired.
Then let's do it quickly. Go ahead.
Oh, no, I'm joking.
No, you can do it.
I got this. Log, big log, x minus 5 divided by x plus 2
Mm-hmm.
equals 1.
Mm-hmm.
And then we rewrite that as 5 to the power of 1 equals x minus 5 over x plus 2.
Mm-hmm.
And now we can, let's see, it will be 5x plus 10 equals x minus 5.
5x plus 2 equals x minus 5. So 5x plus 10 is x minus 5.
That's fine. Oh, no. You subtract the x from both sides.
Subtract x, subtract 10.
That would help. 4x will, later on.
Mm-hmm.
Negative 15 over 4.
So x equals -15 over 4. And does it work? Let me just check only the middle, because we only care about the middle. The x minus 5 means negative 15 over 4 minus 5. And here x plus 2 means negative 15 over 4 plus 2. If you add two negative numbers, what result you get? It's negative. So you don't even care about this one. As long as one thing doesn't work, doesn't exist, the whole thing doesn't work. So what's the solution? No solution. The work we had, it did not work. The enemy doesn't exist. What doesn't exist? You have to say no solution. Or solution DNA, when solution doesn't exist. So that there is no solution. No, two more types. We still don't have an hour, guys. There are only two more types. That's it, two more types. And then you're going to in the third type, we have two logs on both sides. When you have two log, we're going to use, let me go back real quick. The second property. Two logs on both sides without anything extra, we are allowed to cancel them. But we cannot have anything extra. But here, do you have anything extra? The 2. So how can you get rid of the 2? If you have a coefficient, turn it into power so that you do not have anything extra. So we get log of negative 2x equals log of x plus 1 squared. So now there is nothing extra on the left, on the right. We have only logs. So what do you do? We are allowed to cancel them. The negative 2x is x plus 1 squared. And what is x plus 1 squared? Do you distribute or do you do what? FOIL. Good job. You remember. So what do you get when you FOIL?
X squared plus 2x plus 1.
Perfect. And then we need to bring everything to one side so that we can see 0. And we get x squared plus 4x plus 1. And then we are stuck.
Oh, we're done? Because
This is not factorable. If it's not factorable, we use AC is factor for factoring. This is not factorable. Quadratic formula or perfect square. One of them.
Oh, the big ass one. Oh.
I don't remember it.
Wait, I got it off memory.
Negative b plus minus radical b squared minus b over 2a.
Good job. So x squared plus 4x plus 1 equals 0. X is negative b plus minus b squared minus 4ac over 2a. So what is negative b? No, this is positive 4. So negative b is negative 4. 4 squared minus 4 times 1 times 1. Whole thing divided by 2 times 1. Minus 4 plus minus 16 minus 4
I know the answer.
over 2. What do you have?
2 radical 3.
Good job. This is 12, but 12 is square root of 4 times square root of 3. And square root of 4 is 2, so it becomes 2 square root of 3. Divided by 2. So we have negative 4 over 2 plus minus 2 square root of 3 over 2. But they can cancel them, right? It is 4. we get -2 plus minus square root of 3. So we have two solutions, but do you accept both solutions? We have to check. So let's take the first one, -2x. Uh, yeah, we have -2 times -2 plus square root of 3. And then -2. I feel like this answer should be simpler one. Something is wrong actually. -3.
Oh, that's negative, that's positive 4 minus.
4 minus 2 radical 3. And this is 4 plus 2 radical 3. So definitely this answer is acceptable because this is plus. And how about 4 radical 3? Radical 3 is 1 point something. 2 times 1 point something, is it bigger than 4 or smaller than 4? Smaller than. This is also positive.
We have to check the other.
So for the first one, it's okay. But for the second one, is it okay? And since we are not allowed to use calculator, so something is missing actually here. Probably I wrote the wrong
Then it doesn't work.
equation.
No.
Let's check x plus 1 here. I don't have space there.
No, it's not possible.
So -2 plus square root of 3 plus 1. And we have -2 plus square root of 3 minus 1. Which one is positive? This one is -3 plus square root of 3. Obviously, -3 is bigger than that. So the positive one doesn't work. Wait, both of them are negative. Both of them are positive. Come on, what's wrong with this? Oh yeah, negative one doesn't work because you get double negative. -2 minus 3 minus radical 3 gives you a negative result. All of them are negative.
Positive.
So only solution is -2 plus square root of 3.
Wait, then where do you get -1? When you're checking over for
Because I made a mistake, it's a plus 1. So you have -1 minus 3, but still negative.
Okay.
Because you're adding double negative. And for this one, we get -1 plus radical 3. And obviously radical 3 is bigger than -1. It's positive.
positive.
So this is the only solution. Only.
You gotta multiply.
In the exam, they're going to give you a whole number. So I feel like I'm actually missing something inside my log. The -2x, probably I have a number in the front and I just didn't type it. I mean, I typed it, but the technology didn't recognize it. Yeah. I have to double check this one. But this is the type thing. And the last type is, what if we have all the logs? 3 logs.
Bring you one big one left and a small one.
Good. First, you have to combine them. When you combine them, you can have a single log. Remember, you cannot cancel unless you have a single log on both sides. So the right side have a single log, means 1 log, but the left side doesn't have a single one, it has a double log. So convert. Log base 2 of what? Is it? This time it should be times because it's a plus sign. Plus means multiplication. Log base 2 of 3. Now you're allowed to cancel them. And we can also distribute x squared minus 3x equals 3. Man, again something is wrong. But you get the idea. We're not going to solve it, okay? You have to tired. X squared minus 3x minus 3 equals 0. And then solve. Let me see what the original one should be. The answer is 5, negative 5. So what number we can put in the part in here so that the answer becomes 5 and negative 5? The answer is 5 and negative 5. So one of these number is wrong. I'm assuming that 3 is wrong, log 3. What can I put here so the answer will be 5 and negative 5? X squared minus 9. No, I have to check. I don't know what's wrong with all of this. I have a good one, I hope. It's not factorable. Two numbers multiply to 2, multiply to 3, add to 3. No. So I'll fix it, okay? And then in our next class, we're going to do the correct version of the equations. Now the last question for today. Last question, okay? Any volunteer besides Gur?
Okay, me then.
Any volunteer besides Terence? From this side, Ronald. He didn't try anything yet today. B.
First, you would rewrite the left side as 1 log,
Mhm.
log. X plus 3 times x
Mm-hmm.
equals log 40.
Mm-hmm.
And we cancel out the log, it would be x plus 3 times x is 40.
X plus 3 times x equals 40.
X squared plus the x is 40. And then the 40 to one side, so x squared plus 3x minus 40 equals 0.
Mm-hmm.
Positive 8, negative 5.
Hmm. What two numbers?
Positive 8, negative
Positive 8, negative 5. So x plus 8, 0, x minus 5, 0. So what's the answer?
8.
Okay.
8 will have
Mhm. So you have to check all these insides. Oh, the last one we want to check. We have x plus 3 and we have x. When x is negative 8, we get negative 8 plus 3 and negative 8. This is negative, this is negative. Do you accept x equals negative 8? We cannot. Then we are going to check x equals 5. So we have 5 plus 3 here and 5 here. This is positive, this is positive. So we accept. Huh? And that's it for chapter 12. We are done in chapter 12. So in our next class, which is next Tuesday, you're going to take a quiz. You're going to take a quiz on graph, either logarithmic or exponential, one of them, and solving either logarithmic or exponential, one of this equation. So one solving equation from logarithmic and exponential, and one graphing question from logarithmic and exponential. Okay. So study all 4 topics. I'm going to give you 2 topics, and I can give you 2 topics extra credit. Say goodbye, everyone. Yeah, please. And don't forget to start doing your homework.
I'm good with you.
You too. Let me take that.
Thank you, Professor. Have a good weekend.
You too. Be safe. Don't forget to do your My Math Club. Which one? Bye, Eliza. Okay, let's,
Hi, Dave. I don't know. So sorry.
table equation base. Is it a scientific calculator?
Yeah, supposed to be.
It looks so complicated.
So which one?
It does look complicated, right? Like, doesn't it look complicated to you? If it's a scientific calculator, you're allowed to use it. But is it a scientific calculator? Let me see.
That's what it-
Casio advanced scientific calculator with high resolution. Yeah, I'm gonna mark it present.
I was like stuck in my train for like an hour because somebody got injured on the track. Like, I had to stop all the trains going to that.
Wow, which train is it?
Train.
Each way? Unbelievable. Okay, I think it's too advanced for you.
So.
Get something easier, which you can work with. Normal scientific ones.
Like the 284.
84 is not scientific, it's a graphing.
So I'm guessing this one.
This one is much more easier.
I'm talking about the calculator that's gonna be approved. Here's this. Because some teachers like writing in pen and others are like